We're going to be looking at simplifying radicals. When we're simplifying radicals, what we need to do is remember certain radicals are able to simplify. The first one is 1. The square root of 1 is 1. Next one would be 4. Square root of 4 is 2. The next one, you could probably guess, would be 9. Square root of 9 is 3. The next one we're going to look at would be the square root of 16, and that right there is 4. And the last one is going to be 25. Square root of 25 is 5. Now, obviously, you get the point, and you could keep on going to 49 and 64 and so on. But that right there, if you know those 5, that pretty much makes it easy to simplify radicals. So when we're looking at the first one, this is pretty easy because it's 64, and we know automatically that it's 8. When it gets a little complicated is 12. 12 is not one of our numbers, so what we're going to do is we're going to break it down into a number that we actually know. Now, some people might say 2 and 6, but we can't find the square root of either one, so that doesn't work. What I'm going to do is I'm going to pick the numbers 4 and 3. The reason I'm picking these numbers is because I know the square root of 4 is 2. So simplifying, the square root of 12 would be 2 square root of 3. Sometimes we say 2 rad 3 because this right here is called a radical. So when we're looking at letter C, what we have is 6, and we're going to break up 75. And I know that 75 is 25 and 3. So that means the square root of 25 would be 5. 6 times 5 gives me 30. And since I still have a radical 3, I'm going to put the square root of 3 down. And so my answer is 30 square root of 3. Now we're going to move to adding and subtracting. If we're looking at letter G, notice that they both have like terms. What we mean by like terms is they both have the same radical. This is square root of 2, and this is square root of 2. So when we subtract them, we're going to go 4 minus 6, which is negative 2. So it's negative 2 square root of 2, and that's our answer. With letter H, notice that these radicals are not the same. In order to add them, they need to be the same. And I know that 18 is 9 and 2. The reason that I'm picking 9 is because I know the square root of 9. And when I'm thinking of 50, I'm thinking of 25 and 2. Notice that in both of these cases, I'm picking numbers that I actually know the square root of. So the square root of 9 is 3. 6 times 3 gives me 18. So that's 18 square roots of 2. Square root of 25 is 5. 7 times 5 is 35. And then we have the square root of 2. Now I'm going to add 18 and 35, and that gives me 53 square root of 2. Now looking at letter I, I'm going to be subtracting them. First thing I notice is that these are not like terms. In order to subtract them, I need radicals that are the same. I know that 12 can simplify to 4 and 3, and I know that 27 can simplify to 9 and 3. Notice once again, I'm picking numbers that I actually know the square root of. The square root of 4 is 2. 4 times 2 is 8. Square root of 9 is 3. 2 times 3 is 6. They both have the same radical, so they're like terms. 8 minus 6 is 2, so my answer is 2 square root of 3. Now we're going to move to multiplying. When we multiply, we don't need like terms. We're going to multiply the numbers on the outside of the radical and the numbers on the inside. If we don't see a number on the outside, we know that it's 1. So 9 times 1 gives me 9. 6 times 2 gives me 12. We've been doing this radical for a little while, so you're probably getting good at it. We know that 12 is 4 and 3, and the square root of 4 is 2. So my answer is 18 square root of 3. With letter N, I'm multiplying. So I multiply the numbers outside and I multiply the numbers inside the radical. 3 times 7 gives me 21. 2 times 10 gives me 20. And I know that 20, two numbers that make up 20, would be 4 and 5. Once again, I'm picking a number that I know the square root of, and I know the square root of 4. So the square root of 4 is 2. 21 times 2 gives me 42, and then I have square root of 5. For the next one, whenever we square something, we're multiplying it by itself. So what we're doing is we're multiplying it by 2 square root of 3. So 2 times 2 is 4. 3 times 3 is 9. And I know the square root of 9 is 3. So my answer is 12. The last thing that we're going to do is we're going to be dividing. Now, there's 3 different types of dividing problems. One is dividing problems where we know the square root. The square root of 1 is 1. The square root of 49 is 7. That one's probably the easiest. The second one is where we can't simplify the denominator, so we have to rationalize it. Rationalize is a fancy word for saying we multiply the radical on the top and the bottom. 3 times the square root of 5 is 3 square roots of 5. 5 times 5 is 25, and we know that the square root of 25 is 5. Now, the reason that we rationalize is because mathematicians don't like radicals in the denominator. So in this case, there's no radical in the denominator, so it's rationalized. And then our third one is where we can simplify the denominator. This would be 2 and x. And then we simplify the problem, and that would give us 8 over x.